It is my pleasure to introduce Polkadot co-founder and Thiel Fellowship recipient, Parity Technologies core developer, Robert Habermeyer. He's going to bring us all up to speed on why parachains are positioned to disrupt the Layer 1 landscape, secured and connected by the Layer 0 meta protocol provided by the Polkadot Relay Chain. Rob is here with me in New York. Welcome to the Polkadot Decoded main stage, Rob.
Thanks, Peter. Thank you very much. Yeah, today I'm going to be talking about parachains. So if you're new to Polkadot, you've probably heard this word thrown around in a few different places. Like, this is really the core technology of Polkadot. Polkadot is all about parachains and progressing those parachains so we can have all of those different chains moving together. A little bit about myself. My name is Rob, full name Robert. Most people call me Rob. I'm one of the founders of Polkadot, and I've had the honor of leading the parachains core development process over the last several years to actually implement that code and work really closely with some of the researchers, that you saw in the video prior. I've split this talk into a number of sections to sort of talk about different aspects of parachains. So the first aspect is just this disruptive aspect. What is it that we're really setting out to accomplish? And on a very high level, it comes from this fact that our world and the systems that make up our world are ever more complicated. There's a lot of interplay and chaos, and the systems can't keep up with either the amount of people or the amount of data, the amount of traffic, the amount of nuance. And we're spending a lot of time lost in details and regulation and oversight and just bogged down in paperwork. So that's kind of the motivation of crypto and of Polkadot and what we're doing here. Our ultimate goal is to allow people to transact more fairly and expressively, as in give people access to opt into rules, to rule sets, and collaborate with each other. And to focus on what is truly important to them, instead of spending time navigating complex bureaucracies and systems, that they can focus on doing meaningful work or bringing people together or doing what is really important to them. That's a very personal question, but I'm sure we all have the experience of spending far too much time on things that are not important. And really, I think one of the draws of crypto is that it's going to allow people to eliminate a lot of inefficiencies in organization and collaboration. So parachains are the realization of this last decade of blockchain development, technologically and philosophically. They're something new, something that's been sort of talked about and on paper for a long time, but paper is not reality. Reality is what code is out there that is executing. And that's really what we've set out to do, was not just solve something and write a mathematical style proof of it can exist, but really to go out and build it. So parachains, as they're in the launch process now, are this realization of that entire process. And what you can do with them very broadly is to disrupt the ways that we interact with the internet so far. So changing the way that we're going to transact, build, organize, and govern. So having new means of exchange, payment, finance, savings, ownership. As we've seen already over the past year, that has changed substantially. But furthermore, we're going to have different types of entrepreneurs and business models, ways of funding people and teams and interacting with other builders. There are going to be new interfaces, economic primitives, libraries, and cryptography, just things that were not possible without having this decentralized source of truth and trust. We're going to allow humans to be brought together in different ways. So communities, self-organized communities, and also for those communities to govern themselves and have clear binding rules of how they upgrade. And I think Polkadot itself is a fantastic example of a self-governing system, because it has this governance process for updating and bringing in the newest developments to the code as we go. But this is also happening on a much smaller scale. Governance tokens and projects that have their own governance processes. We're going to see this almost on a fractal level, cascading through the smallest projects all the way up to the top of the highest projects. And I think this concept of self-organized blockchain token communities is really interesting because it's very, very internet native. You're going to have people from, all different walks of life, all different backgrounds and sources, wherever they come from, organizing around some common goal or principles. And the diagram here kind of shows that by having different sort of shapes made up of people that are coming out of, that are distributed globally and organizing around Polkadot. Parachains are disrupting all existing blockchain technology. To get a little bit more specific, I'm talking about both existing layer ones and smart contracts. So we've got these three key metrics of sovereignty, inherited security, and specialization. So sovereignty is like how control of its own destiny an object is. And smart contracts are very subject to the system that they occupy. Inherited security is about whether you need to gather your own validator set, whether you, as a developer, when you're building one of these systems, are going to have to worry about providing economic security and making it too big to attack. And specialization is about the ability to suit the solution to a specific problem domain. The more specialized you can get for a problem domain, the more efficient your solution is, the more scalable, the more people can transact using it. And we've designed parachains to try and tick all of those three boxes where smart contracts and layer ones right now don't really. So we're going to have to look a little bit closer at the architecture of Polkadot. The way that it works is you've got a relay chain at the center, and you've got various parachains being secured by that relay chain. And those parachains, you see the way that we display them here is all around the relay chain. And each parachain has its own validators, collators. Some of those parachains are in fact bridges to other networks. And we've also got over in the bottom left corner this notion of parathread. So those are sort of a different type of parachain that has a different scheduling mechanism. And I'll talk a bit more about that later. So to talk a bit about how parachains are changing smart contracts and disrupting them, the fact is that smart contracting platforms are generally too general for most use cases. You've got very coarse instructions, things like add a number, subtract a number. And if you're trying to build any type of complexity out of that, the inefficiencies basically get displayed as gas fees, right? Because you're charging a fee after every addition, every subtraction, whatever it is, those gas fees pile up and it becomes less computationally efficient. It's also less economically efficient. Whereas with parachains, you can really specialize to that use case. You could have a single transaction that just says, store this file. You could have a single transaction that says, pay my rent. Stuff like that that really is more self-contained than a million different small instructions. And I think one other key difference between parachains and smart contracts is that parachains are proactive, not simply reactive. The way that smart contract frameworks work is that they respond to events that are submitted as transactions to the blockchain. But you can't write a smart contract that says, wake me up in a year, wake me up in a month to perform this work, or I want to do this piece of work every block. And when you're writing a parachain as a developer, you actually have that control to schedule logic to execute at particular times or block heights. Parachains are disrupting layer one blockchains primarily due to the fact that it's got a heightened level of ease of communication. So layer one blockchains are not very efficient to bridge to each other. You can bridge them, but ultimately you have two consensus systems with two validator sets, and creating this bridge and proving to one chain that the other chain has, say, finalized a block or accepted some transaction is a pretty bulky proposition. It usually involves lag and latency. So the interesting thing about parachains is that since all parachains are secured by the same consensus process, messages can pass between parachains pretty much instantaneously, within a block or two, which in in the blockchain world is very, very fast. The other factor is that when you're building a parachain, by virtue of that parachain being part of the consensus system of Polkadot, you don't have to gather your own validator or miner set to participate securely. You don't have to worry about, gathering billions of dollars of security so that your chain isn't bought up or attacked or 51% attacked in some way. And I think that's a real win for smaller teams that might have a really innovative idea, but might not quite be able to get there in terms of the economic security. Let's talk a bit about parachains as a technology. So what really are these things? What do they do? How do they work? Parachains ultimately are the execution core of Polkadot. Pretty much any type of transaction, except for simple transactions that are very crucial to the root of Polkadot, things like balances and staking and governance, everything except for those is going to happen on a parachain. So all of the smart contracts, all of the file storage, all of the oracles logic, that's going to happen on parachains. This is where the work is going to happen within the decentralized system. So what are they? Well, the relay chain sort of maintains this set of parachains, and the validators of the relay chain provide consensus for all of the parachains so that they can advance in lockstep. What we're essentially doing is we're taking all of the validators of the relay chain and sort of shuffling them or randomly assigning them to check different parachains at different times. Then they broadcast messages about what they've done to each other, and you can write a bunch of math to show the security properties of the system, which is in fact that it's very secure. Some parachains are going to implement bridges to and from other layer 1 blockchains. So that abstraction of a bridge between, say, something like Polkadot and Bitcoin, Polkadot and Ethereum, Polkadot and Monero, whatever it may be, is going to be encapsulated with the parachain primitive. So you would just register a parachain that happens to be a bridge, rather than having to hard code a bridge into the root level of Polkadot. So what we're talking about here with splitting up the validators across all the parachains is what you might have heard of as blockchain sharding before. But the key difference is that it's a heterogeneous set of chains. It's not a homogeneous set of chains. These chains all do different things. They have different state transition functions, unlike a homogeneous sharding where all the chains do exactly the same thing. Parathreads are a slightly different version of parachains, because when you're acquiring a parachain slot, you're acquiring it for months or years, and you're competing with the entire global parachain community to acquire that slot in auction. And that's worth it if your chain does significant or very time-sensitive work, but for many, maybe the long tail of projects, that's going to be prohibitively expensive. Many use cases will only need to author blocks periodically. Like, what about a blockchain that only needs to author a block once every hour or a few times a day, like whenever some specific event happens? These sort of sporadic blockchains is something that I think could be very useful, but hasn't really been possible before. So the idea of a parathread is a pay-as-you-go parachain. You've got sort of a fixed number of slots that are just reserved for parathreads. You say, okay, this is the pool of 5 slots for parathreads, and then you might have 500 or 5,000 chains that just compete to author a block at every point in time on those slots. So instead of a parachain which holds 1 slot and it's reserved for the parachain, you have parathreads that compete for the slots on a block-by-block basis. So parachains are tools too. And we have different kinds of parachains, right? So rough categorization, we're going to have parachains with tokens that are going to introduce their own native token and pay block authors or introduce some type of new incentivization mechanism. You're going to have parachains that don't have any native token. They're going to be tokenless blockchains that only use the higher level token, which is going to be like your DOT or your Kusama. Those are going to be common good chains, right? Basically extending the capability of the native token of the network, right, to let it be used for new types of actions. You're going to have chains that are specialized to a specific purpose. You're going to have chains that are really good at something like file storage, or really good at something like oracles, or maybe offloading computation, like whatever it may be, identity, zero-knowledge proof systems. And you might have chains that really only do one thing, right? Like they don't even have account systems. They don't even have like governance. They just have this one module that they do really well. And then you can have applications that leverage all of those chains together to create an application that does a whole bunch of things. Or you might have sort of the opposite side of the spectrum, which is your hub chain, where you have a chain that exists as an amalgamation of functionality designed to best serve a specific community. So instead of being specialized on actual transaction types, you can have parachains which are specialized to serve a particular community really well. And those would be things like DeFi hubs, nominator chains, governance hubs, DAO creation facilities, things like that. So I think that's really interesting to think about those two different spectrums that you can fill, specializing on transaction and specializing on community. A couple of examples would be smart contract parachains. You can just have a parachain which is responsible for allowing people to execute smart contracts. So that would be with the Ink smart contracting language developed by Parity, sort of a Rust-like smart contract language, or the classic EVM, Solidity, what you're familiar with from Ethereum or other blockchains. I like to think of smart contract blockchains being specialized in generality, that the whole point is to let people be, write smart contracts. And that gives a lot of flexibility, but obviously it comes with the drawbacks of smart contracts. The cool thing is that it's opt-in. If you want to use a smart contract, you can. If you want to write a parachain that's more efficient, you can do that too. One of the plans that we have is to offload relay chain functionality to parachains. So that would be taking things like staking, governance, and balance transfers actually off of the relay chain. So what you would consider to be the Polkadot or Kusama chain today would actually become a transactionless chain that's responsible for nothing other than parachain consensus. So that would allow the validators of the relay chain to devote their maximum capacity to verifying parachain transactions, as opposed to spending their time on validating relay chain transactions. So wherever you can offload that functionality, it'll create like a really interesting kind of paradigm for blockchain development. And of course, really important are bridges, because I don't think Bitcoin and Ethereum are going anywhere for a while. And we want applications that are built in the Polkadot ecosystem to have access to assets like Bitcoin and projects that are living on Ethereum. So that research is ongoing, being developed, and will be deployed to Polkadot to connect Polkadot to Bitcoin and Ethereum via this parachain mechanism. Parachains are also organizations. So it might be strange to think of them that way, but really, at least community parachains, which aren't common good, they represent aggregated financial and social capital. Groups of people who have come together to pitch in to help that parachain acquire a slot, and also that they'll be working together on the internet. And that gives them some power in the system that allows them to make things happen. So parachains themselves are actually treated as sort of normal accounts within the Polkadot ecosystem. They're allowed to participate in governance. So they can vote on proposals. They can even submit proposals and referendum. They can sit on the council. You can actually have a council member in Polkadot's governance, which is a parachain. And then the way that that council member is going to make decisions is by having an internal governance process. So we might even see this sort of hierarchy of execution that comes from the parachains mechanism also start to reverberate into a hierarchy of governance, which is going to be really interesting to see. They can also curate bounties and have their own treasuries. Polkadot's got a treasury, Parachain X and Y might also have treasuries, and they can allocate those funds however they see fit to best serve their community. You could also think of parachains as digital nation states. They trade, and Polkadot enables them to trade. And different parachains are going to lean into different comparative advantages. That might be community, that might be certain technology that they have. And then this cross-chain message passing feature that Polkadot has will allow them to essentially engage in international trade, but in a digital way. So in the last section of the talk, I'll talk about the software and the development process, because ultimately this is all code. So the last two sections of the talk have been very abstract and thinking about what does this mean? What are we trying to do with it? But this is really what have we built. So first of all, I think it's important to highlight developers. It's not all the developers, not an exhaustive list, but these are some of the really core people who are getting the code done day in, day out. Very important to the project. One of the big things that we've been doing for the Parachains V1 implementation, as we've been calling it, which began in early 2020, was to build something called the Polkadot Parachain Host Implementers Guide. And it's sort of a bridge between research and development. It allows to set the stage for alternative clients and future developers because it's essentially a spec, but it allows researchers to understand what the code is doing. It allows coders to understand the research at a much lower level that addresses all of the granularities that you encounter when you're really trying to build software. It serves as a reference manual and testing ground for ideas so we can iterate much faster. And this has been a really crucial component. You can find this online. It's like tens of thousands of words, but if you're a developer who's interested in this stuff, I say it's probably the ultimate resource to understand how the Polkadot code base works. To give some numbers about the code, over the last, I'd say, year and a half, we've written about 65,000 lines of code just for Parachain. So that's just Parachain runtime modules, Parachain networking code, and Parachain execution code. And these aren't Parachains themselves. This is the code that executes and acquires consensus on Parachains. Over 800 pull requests and over 150 different things that we've tagged as features or enhancements as we've been developing. We've split that up into 23 different node-side subsystems. So those are different modules that are responsible for different things like availability or validation or databases and things like that. And 16 runtime modules, which are actually the modules that we deploy on-chain to facilitate Parachain consensus and make sure that the blockchain can understand Parachains. We've done a lot of testing over the past couple of months with the Rococo network, which we've gotten up to 900 validators and 15 Parachains. And I think we could have done more, but we were really just registering community Parachains, and we ran out of ones that were actually functioning by the time we reached 15. And that's targeting a 12-second block time. There are future optimizations planned that can target a 6-second block time. In fact, the code on-chain already supports that. The code off-chain will need to be optimized to support that. So just to refresh what has really changed since the last Polkadot Decoded in December, we've launched the new Rococo testnet, gotten up to 900 validators, 15 Parachains, and we showed asset transfers and data transfers with XCMP Lite. We completed a sharded security protocol and a runtime codebase audit. There are going to be further audits on the other parts of the code. We launched Parachains on the West End Perma testnet. So we got a shell and I believe upgraded that to statement-style Parachain. We added Parachain runtime modules to Kusama, so actually got the Parachains code, those 16 runtime modules, onto Kusama, and added code for Parachains, crowd loans, and auctions to Kusama as well. So now every Kusama validator node is actually running the Parachain validation code. Released version 0.9.2 and added the first Parachain to Kusama, which is shell and will be upgraded to statement. That has gone pretty well, but there are some stability issues so that we haven't gone forward with the runtime upgrade yet, but those will be resolved soon. What's happening next is, well, ideally auctions, right? Not announcing anything right now, but that is the goal once the Parachain is running really smoothly on Kusama. And having some common good Parachains, community Parachains, finalizing those audits, and then really starting to go through the same process on Polkadot. Like, in my opinion, Kusama has 900 validators and Polkadot has 290 or something like that. So if you can get consensus code to work well on Kusama, it's going to work well on Polkadot as well. So I think that's a key indicator. Of course, there are like more audits and a lot more checking that you want to do because of Polkadot, because Kusama is sort of the chaos and canary network, whereas Polkadot is not. But All that going well, the goal is to begin the rollout onto Polkadot. Our focus on the development side is going to be on optimization and scaling in the meantime. We'd really like to target 50 parachains with 1,000 validators and have that work really smoothly, rock solid, with lots of transactions. But we're also going to be starting to plan out and do those future features of parathreads, off-chain XMP, and off-chain code storage, which are going to be really useful and great performance improvements. And that's it for my talk. So thank you very much for joining, everybody, and I hope you enjoyed it.